Hello everyone, and welcome to BASF's first webinar highlighting the benefits of our recently launched asphalt modifier, B2Last. My name is Trad Kirkland, and I am the B2Last team's Digital Marketing Manager located in Wyandotte, Michigan. I'll be serving as the moderator and technical assistant for the webinar. Today our panelists, Brian Orr and Bernie Malonson, will be sharing some exciting information and new developments in regard to formulating with B2Last. Before we get started, I would like to go over some quick housekeeping measures and cover the agenda. First, I'd like to provide some information on how to use the WebEx platform. At this time, everyone should see the content I am sharing on the left side of their screen and a participants box on the right side of their screen with a list of our panelists, as well as their name under the attendee section. Below the participants box is a Q&A box. Feel free to use the chat box at any time to ask our panelists a question in relation to the content of the webinar. Our panelists will answer your questions at the end of the event. If you have any technical questions, please select Host to direct your question to me. All mics will be muted and will remain muted for the duration of the webinar. Once the webinar is over, we will be uploading a recorded copy to the B2Last website and on YouTube, which we will provide a link to following the event. We'll also provide you with a PDF copy of the slides that are being used. That being said, we are recording this event. Today's agenda includes an introduction of our panelists, an EHS and B2Last overview, detailed information on some of the benefits of formulating with B2Last, completed and planned research and trials, and finally, an open Q&A. Now it's time to meet our panelists. Brian Orr is the North American Senior Asphalt Technologist for B2Last, where he leads technical evaluation and commercial implementation. Prior to joining BASF in 2018, Brian has close to 2 decades of asphalt industry experience, including positions at the Utah Department of Transportation, as well as technical leadership roles in Asphalt Binder laboratory and terminal production and operations management. Bernie Malonson is the North American Marketing Manager for B2Last, supporting industry, Department of Transportation, and academic engagements. He is currently on 4 published and pending asphalt-related patent applications. Prior to joining BASF in 2016, Bernie has held various marketing, business, and product development positions with Motorola Incorporated and Ford Motor Company. Before I hand it over to Bernie to discuss the functionality and benefits of B2Last, it is important that we highlight relevant environmental health and safety information. B2Last is a safe-to-use asphalt modifier that utilizes chemistry that has been leveraged in the construction industry for decades. It follows all EPA and ECHA regulations and provisions, does not require unique PPE, and is less hazardous than other common asphalt modifiers and additives. And with that, the floor is yours, Bernie.
Hello everyone. Thank you for taking the time out of your busy schedules to get an overview of B2Last and how it can help you meet both high polymer and standard polymer modified asphalt specifications while both reducing your total cost of production while keeping viscosity at workable levels. My name is Bernie Malonson and I am BASF's North American Marketing Manager for B2Last. Now a great deal has happened since we released B2Last into North America in the summer of 2020 at the Petersen Asphalt Research Conference. At this time, the global COVID-19 pandemic continues to be a major disruptive force, and the industry remains subject to multiple challenges, whether that is due to budget cutbacks, delayed paving projects, or the need to simplify your operations in order to become more efficient and reduce your overall cost structure. However, BASF believes within every challenge there is opportunity. And BASF is the world's largest chemical company, and although the asphalt industry has traditionally known BASF in North America as a supplier of styrene-butadiene rubber and other SBR latex products used in our asphalt dispersions and emulsions line of products, that is just one segment of our overall construction portfolio and one area of the chemistry that we participate in. BASF has multiple products and technologies with proven track records used in related construction industries that we have drawn from to bring new solutions to the asphalt marketplace to deal with cracking, stripping, and rutting issues. This simplifies your formulations and reduces your total cost of ownership and production while meeting current and future specifications. BASF would like to introduce you to our game-changing asphalt modification technology, B2Last. B2Last brings multiple functional improvements to asphalt binders and mixes in a way that no other single modifier can. One of the best analogies we have come up with is that B2Last brings a Swiss Army knife of functionality and process improvements throughout the entire asphalt value chain. Our Senior Asphalt Technologist, Brian Orr, will speak more on this in just a few minutes. B2Last results in simpler formulations by reducing the number of modifiers and additives needed. Can be produced faster than SBS concentrates, which reduces missed opportunities to fulfill orders. And a surprising finding has been that B2Last ties up and reduces hydrogen sulfide gas emissions, further reducing the cost and need for additional H2S scavengers. With over half a decade of development, asphalt binder and mix testing, and ongoing paving trials, B2Last is an extremely safe to handle liquid modifier from BASF. Over the past several years, our team has quietly been partnering on research projects with groups such as the Texas Transportation Institute, or TTI, at Texas A&M, the Western Research Institute, or WRI, in Laramie, Wyoming, Blankenship Asphalt Tech and Training in Kentucky, and most recently, the National Center for Asphalt Technology, NCAT, at Auburn, which Brian will update you on in a little bit. B2Last supports current Association of State and Highway Transportation Officials, or AASHTO, specifications for both high-polymer and standard polymer modification. When formulated with styrenic block copolymers, most specifically Styrene-Butadiene-Styrene, or SBS, B2Last can actually simplify your formulation while keeping viscosity below 3,000 centipoise. Finally, as we've stated, BASF has developed a safe and repeatable process for using B2Last in the asphalt industry with no disruption to existing processes. In the multiple years and thousands of hours that we and our partners have handled the product in the industry, there have been zero mishaps and no safety violations. It is extremely safe to use. The secret to what makes B2Last such an exciting and an effective tool for modifying asphalt binders is the reactive nitrogen, carbon, oxygen, or NCO molecule used in the formulation. This reactive molecule lets B2Last bind with the asphaltenes in the liquid asphalt binder, improving its functionality at a molecular level in a way a blended product simply cannot. Although the asphalt industry has begun investigating reactive chemistries such as epoxies and terpolymers, research into NCO reactions in asphalt has been sporadic. NCO groups are the reactive material used as a building block in polyurethane chemistry, with the ability to improve the functional characteristics of asphalt binders and mixes. This foundational chemistry is used by BASF to bind crumb rubber in running tracks, or wood particles in engineered wood products, such as oriented strand board or OSB, for example. As I mentioned earlier, BASF has used its expertise to adapt a well-understood area of chemistry used in other engineered, manufactured, and constructed products to the needs of the asphalt industry. One of our key findings over the past few years is that you cannot just drop a reactive modifier into the asphalt binder and treat it as a blend. Now, in traditional formulations, you're blending materials and managing the viscosity. In comparison, in a reactive formulation, you have to balance the reaction against the materials and the viscosity. So it's by understanding these three variables and how they relate to each other that lets you do some interesting and amazing things. As you know, every asphalt is different, and different asphalts have different levels of reactivity. So there is some initial evaluation required to determine the amount of B2Last needed to meet a specific performance grade. However, you do need less B2Last than SBS to achieve similar results. Typical replacement ranges and ratios range from 2% SBS equaling 1% B2Last to 3% SBS equaling 2% B2Last. Now, once you understand the reactivity of your asphalt binder, you can actually balance your formulation to deal with rutting, stripping, and cracking at the same time. So instead of a balanced mix design, it's a balanced formulation design. Now, in the next section, Brian will give his perspective on the value of formulating with B2Last. Brian, the floor is yours.
Thanks, Bernie. Based on some of the initial results that BASF had, they reached out to a prospective customer from Canada to get a binder with varying levels of SBS for evaluation. These were provided based on the supplier's proprietary formulas, so we can't say whether they were using a linear or radial polymer. But as you can see in the highlighted yellow on the slide, The combination of SBS and B2Last modification produced a grade bump of 4 PG grades, taking a 6422 to an 88-22, while maintaining a viscosity well below 3,000 centipoise. This immediately piqued our interest in further studying the synergistic effects of SBS and B2Last. We also ran MSCR creep and recovery tests on these formulations. You can see in the upper left corner of the graph that the 88-22 combination produced an extreme modification with virtually zero JNR and approximately 100% elastic recovery. One potential limitation we are aware of is the test for conventional polymer modification may not actually be picking up the full functional improvements of B2Last modification. This is due to the type of material we're using. B2Last is not a rubber or solid that requires mill time. The reactivity of B2Last forms a network similar to a super ball or bouncy ball rather than the typical elastomeric network noted with SBS. For example, we have been challenged that we are simply stiffening the asphalt and potentially increasing cracking. However, as stated earlier, we are stiffening like a solid rubber ball and can be stiff and flexible at the same time. In separate cracking tests, we have found that we do not harm cracking, especially when used in conjunction with SBS. More to come on future slides on this subject. In order to better understand the effects and benefits of B2Last modification, we had to learn to think about asphalt modification differently than your typical modifiers. For example, we were dealing with a liquid modifier that does not increase modified asphalt viscosity to the level of today's solid modifiers. And as a reactive substance, it bonds molecularly with the asphalt molecules and is storage stable. Essentially, when modified with B2Last, you turn asphalt into stiffer asphalt. There's no notable change in the molecular structure. We have conducted testing noting that B2Last only modifiers are, again, completely stable and have zero separation. We tested separation tubes over the course of 2 months in the lab to see what would happen with no separation occurring. In some of the field trials we did, we ended up storing material for upwards of 3 weeks in inclement weather and had zero separation in those cases as well. Finally, the material imparts elastic functionality in a different manner. As I stated earlier, much more like a super ball rather than a stretchy rubber band. So you can see you have a higher coefficient of restitution due to the nature of B2Last. It's not elastic, again, like a rubber band, but more like it can deform and then 100% recover. In this image, you can see the difference in solid modifiers that must be blended as compared to B2Last, which must be reacted. On the left is an image of SBS polymer in suspension forming a separate matrix from the binder, while on the right, you see how a binder that is modified with B2Last has no separate matrix. The B2Last is reacted within the chemical structure of the binder, causing the B2Last to be completely consumed. This further underscores our statement that B2Last modified binders are much more stable and do not separate like SBS only modified binders can. This also lends to the idea that using SBS in conjunction with B2Last will reduce separation and storage stability issues. Earlier this year at the TRB in Washington, D.C., we were challenged by some transportation officials to look beyond today's specification and see how far we could actually push the technology and improve both the low and high ends of the binder. In this case, in this research, we chose 3 different binders that have different levels of reactivity. From the lowest to the highest, these are the MW1, it's a Midwest binder, a Southern binder, and then MW2, which is another Midwest binder that has a much higher reactivity level. We held the SBS constant at 4% while varying the BASF modifier from 2% up to 3% with the addition of extender oil. One key thing to note from these formulations, they can be varied to get different results. The key thing with this was to heavily modify, check results, and testability. We wanted to ensure that we were well below the viscosity range or at the 3,000 centipoise maximum. We also wanted to make sure that as we looked at the binder, it was actually usable. Previously, we had only expanded 4 PG grades with the UTI of 116 degrees. In this study, we wanted to see if we could expand to 5 PG grades, and we did. The Southern binder, which was originally a 67-22, or a 64-22 for pretty much everywhere else, graded out as a 94-22 with a UTI of 124.4. Although the viscosity did increase above 3,000 centipoise, this can be managed. Again, varying levels of SBS or B2Last can bring this viscosity under 3,000 centipoise very easily. In our opinion, the Midwest binder was the most exciting. In this case, we saw a similar UTI increase to 124.2. However, we also were able to lower the bottom end with an extender oil and keep the viscosity below 3,000. All of these formulations are extremely stable and the results reproducible. Another path of research that can be conducted and will be in the future is use of radial polymers in conjunction with linear SBS and B2Last, or radial and B2Last alone. Using those types of SBS could potentially reach the higher modification levels easier. Each of these tests and formulations show excellent results with respect to elastic recovery and MSCR percent recovery as well. Likewise, using radial polymers in a formulation would likely bring the recovery numbers even higher. I also want to comment that each of these materials looked good. As many of you know, when you highly modify asphalt binder, you begin to see a thickening or sludge formation occurring. This is not the case with regular SBS and B2Last modified binders. As I alluded to earlier, we began to be curious about the cracking resistance of B2Last modified binders. As I presented at AMAT back in February of this year, we saw a very good improvement with the ideal CT index numbers on our first field trials, with just B2Last used in the blend. To begin researching this, we contracted with Blankenship Asphalt Tech in training. Ideal CT index numbers are highly susceptible to low end temperature variations, meaning the lower your PG grade, the better your CT index number should be. Because of this, we opted to formulate the binder to keep the low end temperature within 1% on all formulations. This would enable us to compare the ingredients rather than just the test results. The 4 formulations used a control, just B2Last, just SBS, and then B2Last plus SBS. Due to the synergistic effect of B2Last with SBS, we couldn't keep the upper end numbers the same. The interesting thing to note, however, was the much higher CT index numbers from the SBS plus B2Last. Further research, including stress and fatigue, is being conducted on these binders to better quantify this phenomenon. Thus far, our research shows that when using B2Last in conjunction with SBS, cracking resistance is significantly improved over the individual components. Over the course of the last 2 years, we've conducted multiple field trials. These trials were conducted in Germany and at 2 separate locations in the Midwest. Each in the US used different binder sources and required different specifications to be met. The goal of these trials was to A, prove operational feasibility. We, of course, did not want to attempt to use a product without ensuring it will work throughout the value chain. I, for one, did not want to attempt to pave a road and then have a catastrophic failure occur, like a gelled tank or a solidified mix in a truck or something of that nature. B, we wanted to gather data in regards to mixing, compaction, and other anecdotal findings. As you can see on the slide, we were able to gather quite a bit of this data, which led us down a few other paths of research. C, pave in different climate and traffic regions in an attempt to diversify the type of data we would gather over the course of the next few years. From the previous trials and from experience, we knew we wanted to start an accelerated testing process. We partnered with NCAT to do a phase 1 study, getting a B2Last modified binder on the ground where NCAT can start to evaluate this mixture at a level above regular binder and mixture testing. In early 2020, NCAT was paving the off-ramp to their test track. BASF formulated a binder with B2Last only, meeting M320 76-22 grade asphalt. Testing is ongoing for this section, but thus far the results are promising. No abnormalities were noted in production of both the binder or the asphalt mix. We're looking forward to working with NCAT on more testing and analysis of B2Last modified binders. So what does B2Last do for you? It is a quick and easy method for modification. With a 6 to 8 hour reaction time, it can significantly reduce the amount of time it will take to batch material. With the ability to reduce cracking potential and increase fatigue resistance, your SBS usage can be reduced. This will lead to flexibility in production and the ability to service customers on a short notice. With the reduction in production time, your utility, maintenance, and labor costs will be significantly reduced. To put this in perspective, if you can increase your fatigue resistance, lowering your SBS percentage needed, if you are a plant that makes concentrate blends, this has the ability to reduce the amount of concentrate needed. Reduced concentrate equals reduced mill time. As I previously stated, the reduction in cost when using B2Last is partially based on the large cost of mill time. With the ability to simply inject B2Last into a tank and allow it to mix with little oversight is very beneficial to terminal operations. Some of the anecdotal findings in our trials showed that you can reduce the amount of release agent needed in the bed of a truck. Also, since this is an adhesive, you could potentially save on the usage of anti-strips. When working as an operations manager, one of the largest concerns I had was odor and H2S. I spent thousands of dollars on H2S scavengers and odor masking agents. With the majority of these chemicals, the rheology of binder is damaged when you use them. This created a compensation effect, increasing cost and increasing the amount of modifiers you needed. We have found that the usage of B2Last works as a scavenger and reduces the amount of H2S in the headspace of a tank. It was noted in the trials that there was a significant decrease of asphalt odor while paving. To test for the reduction of odor, we decided to test the headspace of an asphalt sample after the addition of B2Last. On this slide, you can see the control binder was sampled and the headspace analyzed. This was a small sample of asphalt that was heated to 350 degrees Fahrenheit. The amount of H2S read in the headspace was approximately 0.44 parts per million. In another container, we heated the same asphalt and added B2Last. The headspace was immediately sampled after the addition of B2Last. This is represented by the red line on the graph. The lower readable limit of the test was 0.02 parts per million of H2S. The results indicated that we were below the 0.02 parts per million. Further testing to quantify and verify this is underway. What this means, however, is that with the use of B2Last, you now have an additive that will modify your binder, helping the rheological properties and reduce or eliminate H2S. With that, I'll turn it back over to Bernie to cover cost of ownership.
Brian, thank you for that technical overview. As I mentioned earlier, during development of B2Last, we realized that it impacts multiple processes and supports efficiencies throughout the asphalt value chain. However, you can really see the savings within your asphalt terminal operations. As excited as we are about the ability of B2Last to build better flexible pavements, we have always realized that in addition to superior performance, implementing B2Last also has to make business and economic sense. While we understand that every operation is different, in the last year we have developed our total cost of ownership calculator to help our customers and clients model and forecast potential pockets of savings you can tap into when you implement B2Last. For example, the calculator can model potential savings in labor, energy, as well as reductions in the use of other modifiers and scavengers that are no longer needed. Our team is willing to work with your business managers and analysts to walk you through the model and where it makes sense to import your team's actual data and values into the model to provide a customized forecast for you. The calculator lets you conduct a side-by-side comparison of your cost structure before using B2Last and after B2Last implementation. Now, we're prepared to help your business and financial teams forecast projected savings to help you make an internal business case for the technical, operational, and financial impact of implementing B2Last within your operations. Our goal is simple. It's to support your efforts to gain executive sponsorship for an internal evaluation and trial of how B2Last can not only make superior binder formulations, but also contribute directly and impact your bottom line profitability. Again, The BASF team has identified how B2Last improves operations and functions throughout the entire asphalt production and value chain. For DOTs, there is no requirement to change specifications. We are fully compliant with EPA regulations, and we support sustainability initiatives via life cycle cost assessments and environmental product declarations, or EPDs. For asphalt terminals, your facilities can see savings and efficiencies in formulations. You can eliminate the potential for modifier separation in the binder, rapidly produce the material, and increase your safety due to our ability to mitigate hydrogen sulfide or H2S emissions. Finally, for the mixed plants and paving crews, the material compacts in less passes, and it releases from truck beds and hand tools easily, requiring less release agents, and it supports reduced stripping, rutting, and cracking. Now, we can talk to you and share data that supports what we are seeing in the laboratory and paving trials for hours. However, now that B2Last is available for you to sample and evaluate, our goal is for you to see the benefits of B2Last modification and formulation for yourself. BASF wants to earn your business and be your supplier of choice for asphalt modification. As I mentioned at the beginning, times of challenge are also times of opportunity, and we believe B2Last can help your operations and processes become more cost-effective, while at the same time helping you to compete better in the marketplace. Whether you are a regulatory agency or a commercial participant, we believe it is in everyone's interest to create sustainable innovations that deliver economic value while upgrading our road infrastructure and ultimately saving the taxpayer money. This concludes my portion of the presentation. I will hand it back over to Trad Kirkland for some final comments, and both Brian and I will be available to answer your questions during the Q&A segment of today's webinar.
Thanks, Bernie. So now you're probably wondering, how can I get started? First, email us or visit the Contact Us section of the B2Last NA website and enter your information. After you provide us with a liquid asphalt sample, BASF will assess binder reactivity and the initial formulation. Second, B2Last technical teams will provide environmental safety and health training and provide a B2Last sample for your evaluation. Third, B2Last technical support will conduct a total cost of ownership evaluation and site survey to identify potential cost savings and provide options and recommendations for your B2Last implementation. Finally, the B2Last team will work with you to support your commercial paving trials with B2Last and support ongoing sourcing of B2Last for your operations. Please take note of Brian and Bernie's email addresses and feel free to contact them at any time to learn more about B2Last and get started with an evaluation of your asphalt. Also, for more information, please visit the B2Last website at b2lastna.basf.com. And of course, no presentation is complete without a proper disclaimer. Please note the following information in regard to the content of this presentation. That concludes the presentation portion of the webinar. At this time, please feel free to ask any question in the Q&A chat box on the lower right-hand side of the screen. I'll begin reading the questions we received for our panelists to answer shortly.